see you, sir.
Great to be with you, Joe.
It's a perfect time to bring you on because things are getting very wild.
Yeah, there is a lot of misinformation. Some people said I invented 3i Atlas, this object, in order to distract attention from the Epstein files.
Is that what people are saying?
Yeah, and I said, look, this object is the size of Manhattan Island. It's at 4.5 times the Earth-Sun separation. If I was able to put it out there, I would be more powerful than the Pope. And because we're talking about a giant object that you can see from any place on Earth. You can buy online a telescope that will allow you, 0.5 meter in size, that will allow you to see it. It's out there. It cannot be faked.
Well, those people are fools. You can't listen to those people.
I don't listen to those. I don't listen to many people,
Initially, a lot of people were dismissing your concerns, and they were saying that this object is nothing but a comet, and it's very normal. But then as it got closer and as we got more data, it seems like you're correct.
Well,
this is a very unusual object.
There is something really important to recognize here, that usually when you deal with scientific matters, they have very little impact on the future of humanity. Very little. If the neutrino has a little bit of a mass, doesn't really matter. When we discovered the Higgs boson, the biggest impact was to confirm some idea we had back in the 60s. And, obviously that affected, those people who got the Nobel Prize. But most of us continued as if nothing happened. However, here, if we ever encounter alien technology, everything will change. It will affect the financial markets. It will affect politics in a major way. So my point is simple. This is different than other scientific matters. And the intelligence agencies know very well that events with very small probability have to be considered seriously because they could have major implications. Just think about October 7th. The Israeli intelligence agencies had a theory that the Hamas will do nothing. And they got data that indicated something is going on out there, but they dismissed it because of their theory. Now, as a result of their mistake, which was clearly a blunder, a lot of people died on both sides. That this could have been avoided if they were to consider a black swan event, an event that you put a small probability for it happening, but you look at anomalies in the data and say, look, the implications are so huge, we have to consider it. And, this idea was already considered by the philosopher mathematician Blaise Pascal. He talked about God. And he said, look, of course, you might think that God doesn't exist. The probability for that is small. But the implications, if God exists, the implications are so huge that we have to discuss it. That was the argument, Pascal's wager. And the intelligence agencies know that. Believe me, the Israeli intelligence agencies will not make that mistake again. Now, here comes an object from outside the solar system, and it shows anomalies. The scientists would say we should be as careful as possible at talking about anything other than a rock. Now, they say that when they know that humanity launched a lot of space junk, a lot of technological objects to space. And we also know that there are 100 billion stars like the sun in the Milky Way galaxy alone. Most of them formed billions of years before the sun. And there are billions of Earth-Sun analogs. Now, we all believe that we came out of a soup of chemicals. That's the scientific narrative of how human intelligence came on this Earth. And so it's quite likely that, we are not the first one. Sorry to break the news, Elon Musk was probably not the most accomplished space entrepreneur since the Big Bang, 13.8 billion years ago. And therefore, we should consider the possibility that things like us existed long before us. And you can ask the question, how long does it take our own technology, the Voyager spacecraft that we launched out of the solar system, how long does it take it to move to the opposite side of the Milky Way galaxy? Thousands of light years away. It takes less than 1 billion years. And that means that all these civilizations that had their history initiated billions of years before ours could have done it. And all we need to do as responsible scientists is to check if among all the rocks that come from outside of our backyard are really rocks, or maybe one of these objects might be a tennis ball that was thrown by a neighbor. And the reason I say that is, we live at our home, on Earth, next to the sun. We look around us in the cosmic street, and we see a lot of houses just like ours. There are billions of them, probably. Now, my colleagues, those scientists who think traditionally, they say, well, microbes came to Earth very early, therefore they must be everywhere. So let's define our highest priority, searching for microbes on other houses in our cosmic street. And I say, Good. You can do that from the vantage point of your home. You can look through the window and search for microbes in your neighbors' yards. But you would need to put $10 billion to develop a big enough instrument that would be able to detect the chemical fingerprints of microbes, on exoplanets. And think about the possibility that there is a resident in one of those houses. That resident might show up in your front door at some point, or you might see an object that arrives to your backyard or your mailbox from that resident.
Black swan event.
A black swan event. Or you might see some construction project from a distance. That might be easier to detect than microbes. So we should hedge our bets. We should invest billions of dollars on both fronts. At the moment, the scientific community is willing to allocate more than $10 billion to searching for microbes, but no recommendation is made to allocate any federal funding to the search for intelligence. And I say that is an oversight.
Now, they have found evidence of microbes on Mars, correct?
Well, it's not conclusive.
Evidence?
We need to bring materials back. It's called sample return, and NASA has plans. We need to bring a sample back to Earth so that in our laboratories we can do isotope analysis and make sure that whatever signatures we see on the rocks there that do look as if they were made by microbes, because we know that Mars had an atmosphere like the Earth. By the way, Mars may have had life before the Earth because it's a smaller body, so it has a bigger surface area for its mass. The mass of the object tells you how much heat it can retain from the formation process, and then the surface area tells you how fast it can cool. And Mars could have cooled faster than the Earth. So life may have started on Mars, actually, because it had rivers, lakes, oceans of water, and it could have been actually delivered to Earth. We might be all Martians, and when Elon Musk, considers going to Mars, it might be the second trip around. We might be going back to our childhood home because there were tiny astronauts inside rocks that were chipped off the surface of Mars that arrived to Earth and seeded the Earth with life as we know it.
Panspermia.
Yeah, and in fact, we can find out if we get this material back to Earth, as NASA is planning to do, hopefully within a decade, then we can make sure that these were microbes. And perhaps we can infer whether the building blocks of these microbes are similar to the ones we have here on Earth, whether the DNA, RNA kind of process took place in both places.
Have you ever done any research on the structural anomalies that are on Mars, particularly the right angles that appear to be a square, this enormous structure?
Yeah, I've seen the data. It's not conclusive, but it's intriguing because both Mars and the Moon have no atmosphere right now. So what happens on Earth is that when an object roughly the size of a person, or smaller, goes through the atmosphere, it burns up, creates a fireball, just like an atomic explosion, and actually you have an object of order a meter colliding with Earth every year. Every year there is an atomic explosion size fireball in our atmosphere. It's not reported in the news because it happens pretty high at an altitude of 50 kilometers, so it doesn't do anything. And 71% of the Earth is covered by oceans. But these meteors, and they are quite important. Obviously, we know that the dinosaurs 66 million years ago were extinguished by a giant impact by an asteroid the size of Manhattan Island. And we are aware, by the way, that such an impact could endanger us. And that's why the US Congress tasked NASA to find all objects that come close to Earth with a size bigger than a football field, about 140 meters, so that we avoid the fate of the dinosaurs. So we think we are smart, we can see these rocks coming, but just imagine alien technology. It will not follow a path that you expect if it has some intelligence in it. And that's a risk that was never attended to. And I wrote a white paper to the United Nations and to the International Astronomical Union to develop a strategy for monitoring interstellar objects that come from outside the solar system, like 3I Atlas, that show anomalies that could potentially be technological in origin.
The structures on Mars, like what do you think when you look at them? When you see that one that looks like a square? I think
it's very intriguing. Both Mars and the Moon have no atmosphere, so the objects that come into them do not burn up, as I mentioned before about Earth, and therefore they serve as museums. Okay, so any space junk that might have landed on Mars over the past 2 billion years would not have burned in the atmosphere. It would have landed, and we need to check the surface, even if we know that there wasn't any civilization out there over the past 2 billion years because conditions are really harsh.
Right.
Mars may have collected technological debris from other civilizations because it would stay on the surface. It's just like a
Yeah, but
museum.
this is an enormous structure. It's at least they think 300 meters, but
Yeah, but that's not
possibly
enormous because
quite a bit longer.
3i Atlas, the size of 3i Atlas,
Right.
is at least 5 kilometers in diameter. And I derived it in a paper a couple of weeks ago because we know that it's losing mass. So it's mostly from the side that is facing the sun.
Uh-huh.
And you would have gotten some recoil as a result of that in the opposite direction, just like a rocket.
Mm-hmm.
And I used, together with two colleagues, 4,000 data points from 227 observatories around the Earth of 3i Atlas that monitored its motion across the sky. And we were able to say that the trajectory is sculpted only by gravity. There is no evidence for this recoil. And that means that the object is very massive. And I derived a value of 33 billion tons. A huge thing, which if you take solid density, it means it's more than 5 kilometers in diameter. So when you mention a few hundred meters, that's nothing.
Right.
And this object, by the way, was discovered just over the past decade of surveying the sky. So who knows how much debris collected on the surface of Mars or the Moon, because there are good museums. And by the way, I see that as their most important value. Let me just say one thing about my fundamental point of view.
Okay.
Each of us would live for about 100 years if we are lucky, right? That's the kind of... It's pretty depressing, right? Because there is so much we would like to know, and we have only 100 years. And that already tells you that you need to be modest and humble because you don't have a lot of time, right? So why engage in conflicts? Why reduce the lifespan of other people, in wars? It makes no sense, all of this.
Right.
You have limited time. Let's just use it for something constructive. Anyway, we are born on this rock, which is just 3 millionths of the mass of the sun. It's leftover material from the formation process of the sun. Some debris was left over in a disk, and the Earth was made out of that. That's it. And it's just a speck of material, nothing significant. And this Earth was moving around the sun 4.54 billion times before the Vatican even existed. And why do I say the Vatican? Because the Vatican put Galilei in house arrest when he said, I don't think everything moves around the Earth. I see some moons through my telescope. I see some moons around Jupiter. They don't seem to revolve around the Earth. They revolve around Jupiter. Therefore, the Earth is not at the center. So they put him in house arrest. Today, they would have, canceled him on social media. And my point is, that's the first sign that, humans they want to think that it's all about them.
Right.
And it's not surprising. But the Vatican admitted their mistake. In 1992, they issued an official letter saying Galileo was right. That was 350 years after he died. And, it's the worst public relations affair that you can have to admit that you were wrong for 350 years. And how could they have avoided that? Very simply, if they said, we have more money than Galileo, we will build an even bigger telescope to figure out the truth, and we would prove him wrong. And then they would have found that he was right. And so then they would have corrected course shortly
Or
after.
they would have put more people under house arrest. That's probably what they would have done.
Yeah, so my point is, it's really important in cases like this or 3i Atlas, it's really important to get as much data as possible. Because once you reach a certain threshold, you can't shove anomalies under the carpet of traditional thinking, the way that my colleagues do. Just to give you an example, the first interstellar object was Oumuamua, okay? And it was discovered 2017, and it was really strange because it was shaped like a pancake based on all the data we have, and it was pushed away from the sun by some mysterious force without showing any evaporation, no gas or dust around it. What did these conservative comet experts say? Most recently, just in December 2024, there was a paper of them saying it's a comet. It's a dark comet. In other words, a comet where you can't see the cometary tail around it. So it's just like experts, specializing in zebras. And they go to the zoo and they see an elephant. So then they say, oh, the elephant is a zebra without stripes. And I say, no, it's a completely different animal. A spacecraft would appear differently than a rock, than a comet, because it will not have a cometary tail. It could be propelled by something else. So let me go back to the big picture that I mentioned before. So we live on this Earth, moving around the sun, and my colleagues in academia, one thing I often say is common sense is not common in academia. Because my colleagues in academia know very well about the story of Galileo. They know very well about the possibility of black swans. And they say, it's an extraordinary claim to imagine something like us, as smart as we are, near another star. And I say, no, it's an ordinary claim. Why would you think it's extraordinary? And by the way, if you decide not to collect evidence, not to look for it, then you will not find it. So I say, extraordinary evidence requires extraordinary funding. You really need to put resources to find the evidence. By not attending to this possibility, you will by not imagining this. And by the way, I much prefer to listen to imaginative science fiction writers, first class, because they're much more interesting than second class scientists who don't have an imagination. And they not only have a problem with discussing alien intelligence, they also have a problem with whoever discusses it, and they would try to suppress that voice. And I think it makes no sense whatsoever, because the public really cares about it. My essays on medium.com, they get a few million readers a month now. The public cares about it. The public funds science. Therefore, scientists should attend to this question: are we alone? It's the most romantic question in science. It's like. So just to finish my big picture before we get to more. So then, we live on this planet. Everyone says, okay, we are not at the center of the universe, but we might be the only intelligent species out there.
This episode is brought to you by Happy Dad Hard Seltzer. A nice cold Happy Dad is low carbonation, gluten-free, and easy to drink. No bloating, no nonsense. Whether you're watching a football game or you're golfing, watching a fight with your boys, or out on the lake, these moments call for a cold Happy Dad. People are drinking all these seltzers in skinny cans loaded with sugar, but Happy Dad only has 1 gram of sugar in a normal-sized can. Can't decide on a flavor? Grab the variety pack. Lemon lime, watermelon, pineapple, and wild cherry. They also have a grape flavor in collaboration with Death Row Records and Snoop Dogg. They have their new lemonade coming out as well. Happy Dad, available nationwide across America and in Canada. Go to your local liquor store or visit happydad.com. For a limited time, use the code Rogan to buy 1 Happy Dad trucker hat and get 1 free. Enjoy a cold Happy Dad. Must be of legal drinking age. Please drink responsibly. Happy Dad Hard Seltzer, Tea, and Lemonade is a malt alcohol located in Orange County, California.
Again, we need the next Copernican revolution, the next Galilean revolution, to realize that there is a smarter kid on the block, okay? And it's just like the experience of my daughters on the first day to the kindergarten. At home, they thought that they're at the center of the universe because they had their learning was based on a data set that was limited to home. It's just like LLMs, artificial intelligence systems that learn from their data sets, and they had limited environment. And then when they went to the kindergarten, they realized there are kids just like them. Some are smarter. So we are yet to mature in that sense. And that's the big picture. Now, why is it so important for the future of humanity? Because, the Earth would not exist forever. By the way, when people talk about global climate change and so forth, they don't realize, the issue is not the Earth. The issue is humanity, the future of humanity. And, the Earth itself would be very likely, based on detailed calculations, it will be engulfed by the sun in 7.6 billion years. And here is something that you won't find much discussed. The moon, because of the friction on the envelope of the sun, will crash back to Earth. And then the Earth will move all the way to the center of the sun. Nothing will be left. No monument will survive 7.6 billion years ago into the future. And we have an obligation. If we want to be remembered in cosmic history, we have an obligation not to go to Mars. That's not really a great vision. Going to Mars is just like, you have a group of chimpanzees living in the jungle, on some trees, and they have some bananas and so forth. And then one of the chimpanzees looks far away into the horizon and says, "Oh, look up there is another region that we can go to." And it actually, it's clear that there are no bananas there. So the same is about Mars. Like Elon says, let's go to Mars to save humanity, but it's actually not a great place to be on.
Yeah, you got to start somewhere. You have to start somewhere if you want to populate a planet.
So here's my point.
Okay, here's your point.
It makes much more sense for us to invest in building a platform in space that can accommodate humans, not rely on another rock that happens to be near us with much worse conditions. It's a desert, no atmosphere. So let's build a space platform, go on it, and make sure that it's safe for humans to live for long periods of time. We can produce artificial gravity by rotation. Now, you say, well, it will cost a lot of money, but we're spending $2.4 trillion every year on military budgets. If we were just to change our priorities and say, we want to build NOx spaceship, in analogy to Noah's Ark, to save humanity from the great flood or catastrophe that will happen on Earth. You build such, you put a fraction of these $2.4 trillion a year. And I'm willing to bet that within this century, our engineers, architects, scientists, if you put a level of funding of $1 trillion a year for the next several decades, we will come up with a concept that can accommodate humans in space much better than Mars can.
Okay. I want to get back to Mars because the structures on Mars, why would you think that they came from space debris rather than a prior civilization?
Because, Mars...
Let's take a look at it first. Jamie, will you pull up those images? So what's fascinating about the images is the right angles, right? Like that one that's good. Like that's kind of crazy, isn't it?
It is.
And that doesn't strike me as something that landed there from space. It looks like a structure. It's too even.
Yeah. Well, it could be.
It could be
if the evolution of intelligence on Mars was accelerated by a factor of 2. You know, that's not a big factor of 2.
Right. Like
meaning
helped.
that intelligence arose on Mars 2 billion years after it formed, rather than in the case of the Earth, 4.5 or so.
Right.
And, one thing I really want to do is if I ever have a say or go to Mars, I would like to visit those caves, the lava tubes in Mars, because they are protected from the surface, bombardment by cosmic rays and all kinds of things happening, the ultraviolet radiation. So in those caves, I want to check if there are any prehistoric paintings or any technological objects there. I completely agree with you. A factor of 2 is not a big deal. And you can ask also whether on Earth there was a sophisticated technological civilization before us that somehow, either through self-inflicted wounds or because of a natural catastrophe disappeared.
Well, there's a lot of people that think that, especially now that they're looking at the pyramids and these structures that appear to be underneath the pyramids that they're examining. Those Italian scientists that have found these structures that are up to 2 kilometers deep.
Right.
There's some wild stuff in Egypt.
Well, I want to see that data. I haven't seen the paper itself. I just saw reports about it. But definitely on Earth as well. And the problem of Earth is that documented human history is only 8,000 years old.
Right.
And 8,000 years, is just a millionth of the age of the Milky Way galaxy. It's nothing.
Are you including things like Göbekli Tepe in that? Because that's 11,000 plus.
So but it's not really documented in written form,
Right.
So I'm talking about, But you are correct that our knowledge of what happened on Earth is really limited because the human species existed for a few million years, and we have documentation at the level of 10,000 years. If you go back to that, it would be 11,000.
Not a lot.
Not much more.
Yeah.
But
the issue is actual evidence, right? There's just not a lot of evidence because a lot of evidence just gets swallowed by the Earth.
Exactly.
Especially over long periods of time, which is why it's so fascinating looking at that thing on Mars, because if there was any kind of life that was capable of building structures on Mars, it had to be a long time ago. Like, when was Mars... there's a bunch of theories. Maybe you can help me. Like, what do you think is the predominant theory that explains the lack of atmosphere on Mars? Do you think it was an impact?
No, Mars is a less massive planet than the Earth, and therefore it has less gravitational grip on its atmosphere. And as to why the atmosphere was lost, there are various ideas. It may have to do with an eruption on the sun that removed it, or the magnetic field, the lack of a strong enough magnetic field to retain the atmosphere. We don't know for sure, but we know it happened about 2 to 2.5 billion years ago, at the middle of its life.
Can I ask you this? At 2.5 billion years, was it closer to the sun?
No. It was roughly
exactly
at the same place.
Same distance? Yeah. Okay.
Yeah. And then
2.5 billion years ago, it lost its atmosphere.
Yes.
So if it did have life, that life would have to... So we would have to be looking at something that's literally 2+ billion years old.
Yes.
The remnants of a structure, which also seems kind of unlikely, right? It also seems like there probably wouldn't be much there.
I actually did a calculation. The biggest risk for anything on the surface is all these impacts by asteroids, and I calculated that...
And micrometeors, everything, right? Because there's nothing stopping.
That's right. And I calculated the amount of energy over a few billion years that was deposited on the surface of Mars is equivalent to, hundreds of Hiroshima-type nuclear explosions per square kilometer. It's really huge.
Right.
And because you're integrating over billions of years.
So that square probably wouldn't be there anymore.
Well, there could be some relics that somehow stick, like it depends what it was originally, if the Empire State Building, even
if
after.
It was enormous and made completely out of stone, like the pyramids. Maybe that's what would be left of it.
Maybe. I think we should be definitely open-minded and guided by evidence. That's the key.
Well, that's what's interesting is because that is evidence.
That is evidence. We should go there, clear the dust and see if it's just a rock that happened to be shaped like that. I mean, you could have rocks that are shaped like that.
Let's bring it back to this. Is it 3AI Atlas?
No, 3I Atlas.
3I Atlas.
So 3 means it's the third object identified by survey telescopes over the past 8 years. We didn't have the technology before that, and so we just don't know how much traffic there is of interstellar.
We missed a lot.
So we had, the first survey telescope that found Oumuamua was Pan-STARRS in Hawaii, and the reason it was constructed is because the U.S. Congress tasked NASA to find 90% of all objects bigger than a football field passing close to Earth. These are potential killer asteroids that can destroy a region on Earth. We want to protect the Earth, so we want to know about them, and they asked NASA and the National Science Foundation to search, to build observatories that will search for such objects. And that's why Pan-STARRS was established. And then it saw a near-Earth object, so they flagged it for that reason. And they realized it's moving too fast to be bound by gravity to the sun. And that was Oumuamua. And then it looked weird. Now, I had no agenda. I was working on cosmology. At the time, I was working on black holes. I was the founding director of the Black Hole Initiative at Harvard, and Stephen Hawking had Passover at my home in 2016. This object was discovered a year later. And I said, well, okay, that's interesting, but it has anomalies. The amount of brightness coming from it by reflecting sunlight changes by a factor of 10 as it's tumbling. That's really strange. And I started getting more and more into the anomalies. And
so
I noticed,
you had no... previous to that, you had no real connection to the UAP phenomenon?
No, zero.
So you're just basing entirely on the data that you were getting from...
Yeah. And
how do you say it? Oumuamua?
Oumuamua.
Oumuamua.
And, I am driven by curiosity. I'm no different than the kid that I was. I grew up on a farm, and people who knew me back then say I didn't change. I'm not willing to change what I say just for political benefit or for just to be liked. But I don't have any social media accounts. I don't care about that. But when something
Thank God. Somebody.
Well, it's thanks to my wife, not God. My wife said, you should not have any footprint on search. So she's really wise.
She's wise.
And that was more than a decade ago.
Wow, she spotted the problem real early.
Yeah.
This episode is brought to you by Netflix. Catherine Bigelow, the Oscar-winning director of The Hurt Locker and Zero Dark 30, takes you deep inside the world of U.S. government and military, a world most of us never see, but that impacts us all. It's an authentic look at how America might respond to a nuclear attack, showing the human side of impossible decisions under unimaginable stress. A House of Dynamite, now streaming only on Netflix.
And now with AI, we're talking about social media on steroids.
Yeah,
it's really bad. By the way, the main problem with AI that I see is not so much that, they will bring calamity on their own. It's that they would drive people to do crazy stuff. So they will manipulate the human mind in ways that will make us the robots. It will not need access to the physical world. It will control the minds of people in a way that will create a lot of damage. And we see that already.
It's already happening
exactly.
with AI.
That's
using
the biggest
bots
risk
on social media.
And nobody is attending to that. And the question is, how do we suppress the amazing polarization that we see in society where, bullets are being shot?
Yeah.
And I really worry about it because, and so humans may actually bring their own doom by self-inflicted wounds because AI manipulates their minds.
I think you're right. I think in that regard, I think people need to stop using it. I really do. I just think it's not good
That's
for you.
what I'm doing.
I just think...
I'm not using AI at all,
You
by
can
the
use
way.
it sometimes, but I treat it like a glass of wine. Like, don't drink wine all day.
I'm working with students, and every now and then a student delivers a paper to me to look at, and I realize some of the references do not exist because I know the literature. That I ask the student, what is this? I've never heard about this paper. And the student says, oh, sorry. And it turns out the AI just took names of authors and faked a reference.
Things, yeah.
And the same thing within the paper itself. There are statements that are clearly because the student was using AI. I'm really worried about that because the young people are not reading.
Right.
They don't read history. So they go to protests that make no sense.
Right.
They don't. And people say, oh, that is always the useful thing to do. But no. This one is triggered by misinformation. It's triggered
and it's organized.
And it's organized, exactly.
Yes.
And so that's one thing. But then they don't go to primary sources to figure out the truth. They don't have critical thinking. And I really feel that this is a big risk because, AI is getting more intelligent, but humans that use AI are getting dumber.
Right.
They don't think. So I think that the AI would supersede the cognitive abilities of humans sooner than expected because humans are getting dumber. I mean, I see that.
No, I don't think people are necessarily getting dumber, but I think they're getting lazy. Because of this. I think the human capacity is exactly the same. I think they need to be taught how to use it.
Well, I get a lot of emails saying, I collaborated with my favorite AI app, and here is what it said. And
yeah, but I think we need to teach people how to use it because it's a new thing. And that I think that's where a lot of the problem comes from. That people are using it in a substitution for learning, but you instead can learn from it.
Right.
But you've got to use it in that way.
So there are two existential risks in our future. One is artificial intelligence, AI. The second one is alien intelligence, also AI. And the question is, which one would arrive first?
Let's go back to, one more time. Oumuamua. Okay, I don't want to screw it up. How large was that?
That was the size of a football field.
So
of all the 100 meters.
Small in comparison to 3i Atlas.
Oh, yeah. That's my point, that 3i Atlas is 1,000,000 times more massive, at least 1,000,000 times more massive than Oumuamua.
Right.
And I immediately, as it was discovered, it was July 1st, and my wife asked me to go on vacation to Aruba 2 days later. And as I was going on the plane and as I arrived there, I realized, wait, that doesn't make sense because we should have seen millions of Oumuamuas before we saw this one. It's so big. And I also realized there is not enough rocky material per unit volume in interstellar space to deliver such a giant rock into the inner solar system within a period of a decade. You would expect it at a very optimistic scenario where you package all the material into objects that are 5 kilometers in diameter. You would imagine once per 10,000 years. So I wrote immediately a scientific paper. My wife was not happy that, on our vacation, I was sitting on my computer, but I just couldn't resist it.
Right.
And by the way, this paper I submitted for publication. That was July 3rd or something. And then the editor said, the paper is fine, but you have a concluding sentence at the end where you say, well, unless the object is smaller than estimated, maybe it was targeting the inner source. That was my solution to say, one way out of this dilemma of why is it so big is if it was targeting the inner solar system by design. And indeed, the trajectory is aligned with the plane of the planets around the sun to within 5 degrees. The chance for that at random is 1 in 500, okay? And it's moving in a retrograde trajectory opposite to the motion of the planets, which is ideal for it to release mini probes that will get into the planets. It gets close to Mars, it gets close to Jupiter, it goes on the opposite side of the sun relative to Earth when it's closest to the sun. And that's the time when a spacecraft could do a maneuver to take advantage of the sun's gravitational assist. All of these are interesting indications that may imply that some intelligence designed the trajectory. So I had one sentence at the end of the paper saying, maybe the trajectory was designed. And the editor said, no. The paper will not get published unless you remove that sentence.
Wow.
So now when you listen to comet experts that say, well, this claim or that claim was never published in a peer-reviewed journal, guess what? They are the editors or the reviewers who are blocking the discussion on possibilities. And I think it's inappropriate, especially in the case of alien technology, because it could be a black swan event. It could be something that affects the future of humanity. And if we behave very conservatively, we might not last very long.
Well, it's also arrogant.
It's arrogant.
Yeah. This object shows that there's no iron.
Oh, no. So then the composition of the plume of gas around
this is before you knew about the composition.
That's right.
That you wrote this paper.
Exactly.
Okay.
And
so as time is going on, you are being shown to be correct.
Well, we found more anomalies.
More anomalies. So this is not a normal thing.
Not a normal thing. So for one thing, there was a glow that looks like an extended feature. And everyone said, oh, that's a tail. That's the signature of a comet.
Right.
And I said, wait a minute. It's pointing towards the sun. It's not pointing away from the sun. Usually cometary tails are made of dust and gas, which is pushed back away from the sun by the radiation and the solar wind, and so this one was pointed towards the sun, not away from the sun. And the question is, why? And actually, I calculated that, it appeared very clearly in the sharpest image we had from the Hubble Space Telescope, which showed an elongation by a factor of 2 towards the sun. But we were looking at it like a cigar. We were looking almost along the cigar long axis, within 10 degrees of the object sun axis. So we were looking almost edge on. Mm-hmm. And I calculated if you were to correct for that, this would be a feature that is 10 times longer than it is wide, and that means it's like a jet. So the object had a jet in front of it towards the sun. The question is why? And, the comet experts ignored it and just said, well, comets are strange. Who knows? But my point is, this is a blind date of interstellar proportions. And my advice on blind dates is not to speak or say what you think this is, but to observe the other side. The best way to respond to a blind date is to observe the other side. Don't speak, just observe the other side, because it may be different than what you think. And maybe, on one of the dates, you will have a serial killer on the other side.
Oh, boy. Now, explain, if you could, how we know the composition of this thing.
So we can figure out composition of a plume of gas by taking a spectrum of it, which means you basically have some kind of a prism that breaks, that light with different wavelengths is bent at different angles. And so you spread the light into the different colors. And if you do that, you can find the fingerprints, the spectral fingerprints of specific atoms or molecules, because each atom or molecule has transitions. I taught it just 2 days ago in a class that I teach that is obligatory at the Harvard Astronomy Department, where I was chair for a decade, like between 2011 and 2020. So this is the mandatory class, and I just taught how, spectral lines emitted by atoms and molecules just 2 days ago. So this is a very well-known thing, and we know the wavelengths of those, and we use them to identify the composition. We know which atoms produce these spectral lines, the fingerprints. It's just like fingerprints, okay? And so what was found, and that's by multiple teams, there are 3 papers on that, we found nickel, a lot of nickel, but very little iron. At first, no iron whatsoever. Now, usually in all the comets in the past, from the solar system and also from interstellar space, there is one comet, Borisov, that was found. It's the second interstellar object, which looked just like a familiar comet. I had nothing to say about that one. It looked like a comet, behaved like a comet. It was a comet, but it had similar abundances of nickel and iron. The only place where we found before much more nickel than iron is in alloys that we produce industrially. For example, for aerospace applications. Nickel alloys have a lot of nickel, no iron. So maybe the skin of this object is industrially produced. That was my suggestion. But what the authors of these papers said is maybe nature is capable of going through the same chemical pathway of producing nickel without iron as we do in our industries. So they made a conjecture that this carbonyl pathway, which is well known in the industry world, carbonyl is the pathway, the name of the pathway. They said, well, maybe this carbonyl pathway happens in nature. We've never seen it before, but that is their explanation.
Is it possible that nature could construct some sort of a nickel alloy?
No, it's not an alloy. It's just that somehow the nickel gets released, the iron gets suppressed. Nobody would argue that you could sort of separate nickel from iron because they're produced together in exploding stars.
Right.
And in fact, the composition of the sun has more iron than nickel. 10 times more by mass. And so we just don't know, as in the case of this jet that I was mentioning, which recently turned into a tail now over the month of September. And also, why was it changing structure is not clear. There are lots of anomalies. There was also a very negative polarization of the light. And also, 2 weeks ago, I realized the arrival direction of 3A Atlas was within 9 degrees of the WOW signal that was detected in 1977, which was an enigmatic, powerful radio signal that definitely came from outside of this Earth. We don't know from where. It was coming from a source that was approaching the sun. And the chance of it aligning with the arrival direction of 3A Atlas is 0.6%. And I just said, well, that's interesting because 3A Atlas was at a distance of 3 light days from the Earth at that time, and you just need about the output of a nuclear reactor on Earth, a gigawatt or so, to produce such a radio signal. By the way, Voyager, right, as of now, is 1 light day away from Earth. Just think about it. 1 light day, the farthest spacecraft we ever launched is 1 light day away, and the size of the Milky Way galaxy, we are talking about tens of thousands of light years. So 1 day out of tens of thousands of years. That's the difference between the distance that we managed to breach so far compared to another civilization that may have sent something to our backyard.
Right. Now, have we ever observed things in the past that have changed their tail like this?
So there are
from
fake...
a jet to a tail?
This is called an anti-tail when it's pointing towards the sun. Mm-hmm. There were optical illusions in a situation where, there is a tail which is pushed away from the sun by radiation and solar wind, but you're observing it as the Earth goes through the orbital plane of this object, of this comet, and you're seeing it from a perspective that it looks as if the tail is pointed at the sun, but in fact it's just a perspective thing. It's an optical illusion. And there were cases like that. That was seen. But as far as I know, none seen in a situation where it's clear. And in 3i Atlas, it was very far from the sun and Earth, and we saw it towards the sun. There cannot be an optical illusion under these circumstances because it was approaching both the Earth and the sun roughly at the same direction. So I'm not aware of another. But most importantly, you should look at the response of the comet expert community to that anomaly. They say, well, comets are strange. We don't know. Maybe it's these are dust particles that are very big, so they don't get pushed back much. But then how do you scatter sunlight? Usually you need particles that have a size of the order of the wavelength of the light that is being scattered. That's the most efficient process. And when you have dust particles, the ones that have, sub-micrometer dimensions are dominating the scattering of sunlight. So why, in this case, you will have only big ones that are not getting pushed back? It could be fragments of ice that are scattering the sunlight that have nothing to do with dust, but those fragments of ice get evaporated, and so they don't have enough time to turn back. I wrote 2 papers on that trying to explain it. But my point is, many scientists are not curious. You would find it surprising. Why are they not curious? Why are they not willing to consider alternative explanations to what is commonly thought? And it's because they're afraid of taking any risk. And I came from a background where I worked in cosmology, trying to figure out puzzles. Like most of the matter in the universe is of a substance that we don't know what it is. We call it dark matter. It's just to reflect our ignorance. Nobel Prizes were awarded for people who quantified how much dark matter there is, how much dark energy there is. These are constituents whose nature is unknown. And just think about it, giving a Nobel Prize to people who just said how ignorant we are. We don't know what these things are. Ordinary matter makes just 5% of all the matter in the universe. And in this culture of cosmology, when I worked in for 3 decades, it was completely common to propose ideas to explain anomalies. I mean, the dark matter is an anomaly. You don't know what it is. And people were rewarded for coming up with ideas, imaginative ideas that can be tested experimentally. That's the way you make progress. You don't know something. You are putting on the table possibilities, and then you motivate observers or experimentalists to figure out which one is the correct one. And that was the culture. And I think of it as a culture of chess players. Okay? Trying to figure out things. When I get to work on comets, asteroids, these objects, and consider imaginative possibilities to explain their anomalies the way I did in the context of cosmology, I encounter, a culture of mud wrestlers. It's different from chess players.
Right.
And I don't want to mud wrestle. I don't want to get dirty. I don't respond to I learned my lesson with Oumuamua. I don't respond to those people because once we collect, I just want as much evidence as possible so that they would not be able to shove the anomalies under the carpet of traditional thinking. That's my motivation.
Right.
So I'm inspiring a debate right now, and there is a huge interest in that debate so that we will collect as much data as possible so that by the end of the day, we'll figure out what our dating partner is. If it happens to be a rock, on the other side of the table, you go on a date and you see a rock, so be it. If it's something else, that has huge implications.
Right.
And therefore, we should consider that possibility seriously and just collect as much data as possible.
What is it about your field in particular that you think motivates mudslinging? Like, why are they averse to risk, and why are they not just averse to risk, but why are they attacking you for proposing what seems to me to be a reasonable alternative, considering the possibilities given all the planets and stars that we know are out there?
Well, I got a hint for the answer to your question. When I wrote the first paper on Oumuamua,
right,
I suggested it might be technological.
Right.
And the paper got accepted for publication within 3 days, record. The reviewer said, this is a great idea because it's consistent with all the data we have. It's most likely a flat object. And therefore, it could be pushed by reflecting sunlight, which was my proposal. Then the media came to my door. And people started asking me a lot of questions. I got well known. At that point, the personal attacks started. So
right.
it's, jealousy. Yeah, it's
jealousy.
But I can tell you that I learned my lesson.
You can't respond.
I just ignore it.
Yeah.
And let me give you a few anecdotes of what happened to me this week, just this week.
Okay.
Okay.
Please.
Tomorrow, I'm supposed to go to California. There is a NASCAR car race where one of the racers decided to put my image with 3i Atlas, with the Galileo project that I'm leading, on his car. So let me show you some images.
Yeah, show me the image, because what is the current best image of 3i Atlas?
Oh, we will get to that. So here you see the car, and he promised to let me drive it just before the race.
Who is this guy?
Alex,
Kevin Harvick?
No, Kevin
Raceway?
Harvick
Oh,
that's the name of the...
What is the driver's name?
Alex Malik.
Alex Malik.
Yeah, and he contacted me out of the blue.
So he's just a big fan?
Yeah, he's just a big fan.
Oh, that's cool.
And I will go there.
Pretty smart of him, right? Because that's definitely going to get you a lot of attention.
Yeah, so he just sent it to me this morning. This is in the shop where they put all these things on it, and tomorrow I'm going to drive it.
What is Comet Lemon in the back?
Oh, that's just another Comet. So
he's like a Comet fan, this guy.
By the way, I told him that the fastest moving race car is 600 times slower than 3i Atlas. 600 times. So,
Wow.
It's a compliment to me to be featured on his car, but 3i Atlas doesn't care much because it's already moving 600 times faster than his car can move. But let's move
That is cool, though.
So this is tomorrow.
That image, though, that's you with a spinning world, right? That's the globe.
Yeah. And my name, so the car is called Avi Loeb now.
Nice.
Yeah. Can we move to the next image? I'll show you
You're
another.
very excited about this. I like it.
Yeah. So this is an image taken 2 days ago in my office at Harvard. I was contacted out of the blue by an artist, a very distinguished artist, accomplished, named Greg Wyatt in New York City, who donated 2 sculptures made of bronze of Galileo. You see them in the front. They were delivered to my office just a few days ago. And in the background, you see watercolors that he made. Each of them, there are 51 of them that he donated. All of this he donated to me at no cost. He wants it to be displayed in my office because these watercolors display famous scientists that pioneered new frontiers. And he includes a statement from each of these scientists, which are really educational for the students and postdocs that work with me. I should tell you, I got an email from a U.S. Air Force pilot. His daughter, Ariana, said to him, he wrote me an email and said, because of you, my daughter wants to become a scientist now. She saw you on television, and now she only speaks about aliens. 2 days later, I speak with a reporter from the London Times, and he puts out his report and says, I read the report for half an hour to my kids, and they told me they want to become scientists. And, this is another thing, that there are 2 things that are missed by my colleagues. One, it's an opportunity to excite the kids to get into science. That's an amazing... I mean, when we discovered the Higgs boson, it was an important confirmation of an idea that came in the 60s. The Nobel Prize was awarded, but I bet you that the daughter, Ariana, the daughter of the U.S. Air Force pilot, would not be inspired to become a scientist because it's very abstract. Here, there is a connection. So that's one thing that is missed. And of course, the second one is, here is a subject that the public cares about, and the public funds science, so we should attend to that.
Of course.
It's our obligation as scientists.
Of course.
Why, I always, since I started science, which was by chance, by the way, I wanted always to become a philosopher, but circumstances led me because I led a project that was funded by the Star Wars initiative of President Reagan. It was the first international project. And then that brought me into astrophysics because I was offered a position at Princeton, the Institute for Advanced Study, where Einstein was a faculty a few decades earlier. So it was an arranged marriage, but I felt that it's even though it's an arranged marriage, I'm married to my true love because I can address philosophical questions using the scientific method, and I recognize things that my colleagues do not because I'm different. I'm just. But
you're willing to take chances.
It's not just that.
Not even chances. You're willing to propose things that might be ridiculed.
Well, I think about the big picture. The one thing that I mentioned in my book, Extraterrestrial, is on the first day of school. I showed up to the class, and I saw the kids jumping up and down on the tables in the classroom. And I looked at them and I said, does it really make sense to jump up and down? Like, what are they trying to accomplish by doing that? And then the teacher came in and looked at everyone jumping and said, quiet down. Look at Avi. He's so well behaved. You should all behave like him. And I wanted to tell her, I'm not well behaved. This was not the reason why I didn't jump up and down. I was just trying to figure out why they are jumping up and down. And if it made sense, I would jump up and down. I don't care about your rules. And that pretty much defines me. I'm thinking about the big picture. And if my colleagues are doing something that doesn't make sense, I don't give a damn.
So let me ask you this.
Yeah.
Once the understanding of the composition of 3i Atlas, once that was out and people recognized that this is a very unusual object, have more people started to consider what you're saying?
Yeah, I get a lot of people sending me
In the academic world?
also in the academic world.
Yeah.
Those are people that say we are inspired by what you're doing. They keep sending me emails saying keep doing it. It's an inspiration to all of us.
But this is privately. Has
Privately,
anybody publicly
exactly.
supported you?
So the young people, you have to understand the biggest damage of this harassment or scrutiny or ridicule or personal attacks. I don't care about it. My skin is by now titanium. I don't really feel much. The issue is really that and that's the purpose of these attacks, is they want to discourage young people from deviating from the beaten path.
Right.
So they keep the herd in a tight configuration. And the risk from that is, one suggestion that was very popular when I started astrophysics, half a century ago. By the way, I lived throughout half of modern physics, roughly. Half of modern physics. So half a century ago, it was thought that there is a symmetry of nature called supersymmetry, and that the dark matter is the lightest particle associated with that symmetry because it's stable.
Right.
And everyone said that must be right, and lots of castles were built on this foundation, including string theory, that was assuming this to be true. And then the Large Hadron Collider at CERN was built for $10 billion, searched for supersymmetry and didn't find it. Now, what is the lesson? Yes, it was a beautiful idea, and sometimes nature is not what we think it is, okay? So we should not ridicule ideas that are different than what the mainstream is doing, because the mainstream makes mistakes. This was, a lot of money and effort went to that. There are thousands of papers basing their analysis or mathematical constructions on supersymmetry.
And a lot of people are unwilling to abandon that as well, right?
Yeah, but the point is, if you allow people to follow not just the beaten path, but other paths, you have a better chance of discovering something new.
Right.
Because we cannot... Einstein made, 3 mistakes between 1935 and 1940. He said black holes probably do not exist. He said gravitational waves probably do not exist. And he said quantum mechanics doesn't have spooky action at a distance. And all 3 received Nobel Prizes for the teams that proved him wrong. Those are Nobel Prizes from the past decade. 3 teams, doing different types of experiments and observations. But did Einstein was wrong to assume, to make assumptions or claims that turned out to be wrong? No, because that's the nature of working at the frontier. You make mistakes. Every now and then, you might be right, and that will be a breakthrough. But you cannot have breakthroughs without taking risks. And it's really, the whole idea of tenure in academia was based on the proposition that you want people to take risks so that they don't have job insecurity. They don't worry about their... So what these zealots, I call them, say is, we don't want people to deviate from the beaten path because we base our stature, we base our honors, awards, and so forth on past knowledge. We don't want new knowledge, unless it's proven beyond any doubt. But how would it be proven if you keep ridiculing anything different? Most of the scientific community thought that rocks cannot fall from the sky. And then in 1803, there was a meteor shower in Liège, and Bayot, a French physicist, realized it's real. There are rocks falling from the sky. Now, all my colleagues say there could be only rocks in the sky. We know that we launched some spacecraft, but, we're probably alone. And it doesn't make sense. But let me just mention a few other anecdotes from the past week, because I didn't really finish. So, Jamie, can you show the next one?
What is it?
This one is about Sphere in Las Vegas. As you know, it's the most impressive venue for entertainment in the world.
Have you been there? Have you seen a show there?
I'll tell you. Not only I've been to the top of the Sphere, which is like 120 meters high. Here you see me from inside the Sphere. This is the exosphere, by the way. It's covered with LED displays. We went all the way to the top. Why? Because a year ago, 2 very distinguished visitors came to the front door of my home. By the way, lots of interesting people show up at my front door. This was Jim Dolan, who owns the Madison Square Garden, as you know, and also the Sphere, and Jane Rosenthal, the CEO of Tribeca Enterprises. And they made me an offer that I cannot refuse. And they said, would you be able to put a Galileo Project observatory? I'm leading the Galileo Project to look for unusual objects around the Earth. And they said, could you build an observatory on top of the Sphere? Because, Jim Dolan really is interested in science, and especially in finding, whether there is some alien intelligence out there. And I said, of course, I will be delighted. So that was September 2024, 1 year after the Sphere was opened with a U2 concert, as you may know. I don't know if you've been there.
Yeah, I've been there for the UFC.
Yeah, UFC, exactly.
Yeah.
So anyway, I was there just a few months ago with my research team. We went all the way to the top. and installed, as you can see here, an array of infrared cameras that monitors the entire sky above Vegas at all times. So you can see some of these images show the landscape of Vegas in the background. It's like a freckle, on top of the sphere, the exosphere,
right.
which is the biggest display on Earth,
Right.
But we measured that there is not much light pollution, actually, and we can operate this observatory. We also put an array of visible light cameras there, and it's operating, okay? And we hope to see a few million objects over the sky of Vegas and decide whether any of them has performance that deviates from the envelope of human-made technologies. How do we do that? We have the sphere as one point, but then we put two copies of that observatory 10 kilometers away on a triangle. And that allows us to look at objects in the sky from different directions, just like we have two eyes, so we can gauge the distance. So here we have three eyes looking at the sky above Vegas, and we can tell the distance, the velocity, the acceleration of objects, and ask whether they are lying within the performance envelopes of human-made objects. And that would be amazing. It's very exciting. I see that also as an opportunity to communicate to the public the excitement about science. That's what Jim Dolan and Jane Rosenthal really wanted to deliver. And I'm hoping that we will find something really anomalous, because as we know, the intelligence agencies are reporting to the US Congress about objects they cannot identify. And, that could be two things. They're getting, the defense budget for 2026 is $1 trillion, okay? If they tell us that with $1 trillion, there are still objects they cannot identify above the US, they're not doing their job. They're not doing their job, and we should be worried. Who sent these objects? Could it be adversarial nations? Okay, that's one possibility which has to do with national security. The second possibility is that it's maybe something from outside of this Earth, which would be even more significant. So either way, we need to figure this out. And I don't think I'm wasting my time leading the Galileo project to figure out whether there are anomalies, that go beyond human-made technologies, because if it turns out that all the objects are human-made, I will be happy to deliver the set of sensors we developed with the machine learning software that we developed to the Department of War so that they can employ it for national security purposes. So my time was not wasted as a scientist. I'm doing something useful to society.
Of course.
The Department of War can use it. Have no problem. Everything made by humans, by the way, is boring as far as I'm concerned. I want to see something from outside the solar system, which is not what the government should be about. The government should worry about national security, not about what lies outside the solar system. That's my job definition as an astrophysicist, okay? And so I feel that this is worthy pursuing, but the Galileo project is really the first organized project that constructed a reliable set of sensors in an observatory configuration that does systematic study of the sky to collect millions of objects in the sky per year. We have 3 observatories, one in Las Vegas, as I mentioned. And by the way, this is the first time it's mentioned publicly. So
that's amazing.
And another one in Massachusetts, and a third one in Pennsylvania. They were all funded by people who approached me and said, here is the money.
Let me ask you this. If it wasn't for those, how many observatories are looking for objects that are not from this Earth? Like, is that
None.
very rare? None?
Well, there are some teams that are, making a trip to collect some data. There is,
But
of
there's
course,
not constant observation.
of scientific quality data. No.
That's crazy.
That's crazy. That's what I'm saying.
That's crazy.
And by the way, I gave a briefing to the U.S. Congress on May 1st, 2025, and Congresswoman Ana Paulina Luna was there, and she was very excited about the work we are doing. But the day before that, I visited an office in the Pentagon that is called the All Domain Anomaly Resolution Office. And I asked them, you looked into all these unidentified objects reported in the past by military personnel. Did anything trigger your attention as something truly anomalous? And they said, not really. There are some reports by FBI agents that saw really crazy stuff, but we don't have any data from instruments. And this is an office within the Pentagon, which is funded to figure out things. And so obviously what they might want to do is imitate the Galileo project that I'm leading. But you would think that it would be sort of the vested interest of government, to invest in research related to that, which is what the Galileo project is doing.
Well, here's the thing. I would have thought it was already done.
I don't know.
Like, until we're having this conversation, I can't believe that they're not monitoring the sky constantly for anomalous objects.
Well, you remember the Chinese spy balloon that was
Yes.
missed, right, and shut down?
Yeah, but that was
so
silly.
the thing to keep in mind, they're getting data on things in the sky, But if you don't have the right software now with AI,
Right.
if you don't have high quality scientists the way that the Manhattan Project employed, you might not figure out things. There is a reason why the Manhattan Project recruited the very best scientists. So I say, put $1 billion on this or more, bring in the best scientists in the world to figure it out. I'm funded at the level of millions of dollars through the Galileo project. The government can do a bit. What is $1 billion? It's a drop in the bucket for the Pentagon. But if you should think about the potential risk from drones that are used by adversarial nations, and you want to have the very best sensors using the very best
Of course.
AI
I just can't
algorithm.
believe that that's not already being done. That's
Again,
what's so confusing.
well-
I would have thought that there was some sort of very sophisticated monitoring of the skies already.
Well, that's
Especially when you take in all these anecdotal stories, all these different stories of people spotting some sort of a ship, something
Right.
that moves in a very strange way.
Right.
I would think that they're monitoring this stuff all the time, and not just with radar.
You see, there is an approach which is to wait for the government to figure out things or to release, declassify them. So a lot of people want the government to
Right.
declassify. I think it's just like waiting for Godot.
Huh.
You can wait forever,
Right.
and it will never happen. So I say, we don't need the government to tell us what is up there in the sky, because astronomy is all about that. We can build observatories, look at the sky. Anything that is human-made is not of interest to me. It's boring. I don't care. I just want to see if there is anything that...
Well, it's boring up to a point. If China has something that moves at Mach 30
Yeah.
and can go underwater,
Yeah.
things get very interesting.
So
when you deal
my
with, like,
methodology
underwater.
should definitely be used by the Department of War
Mm-hmm.
to figure out risks of the nature that you mentioned. And by the way, speaking about my colleagues, so there are people who said, "Oh, you're doing it to win the Nobel Prize. Like that's what or you're trying to sell books." I don't charge a penny for my essays on Medium.com. Money is not at all what motivates me. With respect to the Nobel Committee, I have the same attitude as Jean-Paul Sartre had and Bob Dylan had. If I find evidence for alien intelligence, alien technology, I would not waste my time in a tuxedo in Stockholm. I will try to figure it out. That's much more important than an award given by a human to a human. We're dealing with something really consequential.
Yeah.
And for the scientific community to ignore that is irresponsible. Why is it irresponsible? Because it could affect the future of humanity.
Well, I think the problem with the scientific community is the problem with all communities. They're overrun with ego.
I agree.
It's
And as I
just-
explained at the beginning,
It's just human beings when they get to a position of any kind of authority, any sort of a position of respect and prestige. They want to protect that at all costs, and they want to keep everyone down who they think is getting unwarranted attention above them, like yourself.
but given the fundamental landscape that we live in, as I mentioned at the beginning, we live for a short time. We're not at the center of the universe.
Right.
We arrived late to cosmic history. We just arrived in the last few million years out of a 13.8 billion years history.
Right.
The cosmic play is not about us. If you arrive late to the play, at the end of the play, you are not at the center of stage. It's not about you, okay? And our responsibility needs to be, to find other actors that were around for much longer, because they know what the play is about.
Yes.
And-
let me ask you this.
Yeah.
Have you seen any compelling information, any data that leads you to believe that we have been visited?
The only data I'm aware of that is worth attending to is the anomalies of Oumuamua, of 3I Atlas, which are very different anomalies.
Right.
And there was also a meteor that I discovered with my former undergraduate student, Amir Siraj, a meteor that was identified by US government satellites back in 2014. And it was moving so fast that it definitely came from outside the solar system. And my colleagues were very concerned, and they said, we don't believe the US government. So maybe Jamie can show us. I said, okay, at the time I was chairing the board on physics and astronomy of the National Academies.
Why didn't they believe the U.S. government about this?
Because all the previous meteors they thought must have been from the solar system, and therefore, and the U.S. government also makes mistakes every now and then, they
So
said.
the U.S. government, what department was observing
This
this?
is the Space Force, the U.S. Space Command. So what I did is at dinner.
What year was this?
This was around 2020.
Okay.
And I expressed my frustration at dinner as the chair of the board on physics and astronomy of the National Academies. And there was a member there from Los Alamos National Laboratory. And he said, let me help you. We managed to reach out to the U.S. Space Command through the White House at the time. And we got an official letter from the U.S. Space Command saying, we looked at the data and we can verify the 99.999% that this object, this meteor, which was roughly half a meter in size, came from outside the solar system. That's what they said. At that point, I decided to lead an expedition to the Pacific Ocean, where the explosion was identified from the fireball. There was a huge amount of light. To go there and search for the materials from that object, because it was moving fast. It was moving at 60 kilometers per second relative to the solar system, very similar to 3I Atlas. So it was fast. And moreover, the object maintained its integrity down to the lower atmosphere. It didn't explode until it got within 20 kilometers of the surface of the ocean. So it must have been extremely tough, much tougher than all the previous meteors cataloged by NASA. Okay, so I can show you some images from that trip to the Pacific Ocean. Actually, it was documented by Netflix, and there will be a documentary coming out within a year, next year, 2026. This was the team of researchers that came with me on the deck of the ship, and we collected materials with a magnetic sled. This is a sled with magnets on top of it. You can see the Netflix team at the lower left here. And then I brought the materials in this suitcase that you see here. I shipped it by FedEx to my home. This was a $1.5 million expedition. So
why would you ship it by FedEx? Why wouldn't you just carry it with you?
Because I was worried that somewhere in the airport they would say, no, we have to confiscate that.
But don't they know who you are? Can't you get somebody to call in?
I don't want to take any risk.
So it's just a bunch of metal?
No,
what did you
here
find?
you can see the material. So it's mostly sand from the bottom of the ocean, 2 kilometers deep, 1 mile or so. A little more than a mile. And then I found these, we found these molten droplets, you see, that are very distinct relative to grains of sand. And we isolated them. I had you can see here these molten droplets. And it turns out that 10% of them did not have the composition of materials from the solar system. And so we studied them in the laboratory of my colleague at Harvard, Stein Jacobson. And I had a summer intern, Sophie Bergstrom, that found 850 of those molten droplets that allowed us to do the analysis. How did my colleagues respond to that? They said, oh, he went to the wrong place because there was a seismic signal that could have been misidentified and could have been a truck passing nearby. And so a reporter from the New York Times said, oh, they went to the wrong place because it was not a meteor, it was a truck. And I wrote to the reporter and I said, how irresponsible are you? You didn't even ask me. The data that led us to this place was based on the fireball, on the light that was detected by US government satellites. And the US Space Command confirmed the location. It was not based on the seismic detection of the signal. We just looked and found this.
So it seems like your colleagues are contacting the New York Times to try to dismiss you.
I wrote to the editor at the time and said, look, if this is what you write about science, how can we trust what you write about politics?
Right. Yeah. So these objects, these very small molten droplets,
right.
What did you determine from them?
We found that 10% of them had a chemical composition different than solar system materials that were found before. And again, my colleagues, some of them, said, oh, they found coal ash, the burnt material from coal. So we said, okay, well, let's check. We identified 61 elements from the periodic table and showed that it's definitely not coal ash. And then they said, it's something else from the crust of the earth. We checked that, it's not from the crust of the earth. It's an endless battle to basically, they can throw mud without having access to the material.
I don't understand. This is a known meteorite. It hit Earth. You collected pieces of material from the scene where it hit.
Right.
And they still want to dismiss it.
Yeah, they say the government cannot be trusted. They raise a lot of dust. If you raise a lot of dust, you can say, I don't see anything.
Well, you get the New York Times involved, too, which is even stupider.
Well,
that's so crazy that the
New York
Times
crazy.
Jumped in without contacting
But this is the landscape I have to operate in. And the one thread through this landscape is that common sense is not common.
Right. Well, it seems more than that. It seems like a coordinated attack. It seems like a bunch of people have a personal vendetta.
Yes.
Which is probably based on some petty jealousy. And also, they just don't like people stepping ahead of them.
I told my students in the class, I said, on the first class, I said, what is the strongest force in academia? It's not gravity. It's not electromagnetism. It's jealousy.
I would hope it's curiosity. That's what sucks.
That's what brought me into science.
Well, that's what you display.
And I'm naive. I don't change my reason for doing something just because other people misbehave. I feel like I'm attending a party where the attendees are misbehaving, and all I can hope for is for a guest to show up and change the situation. One reason I'm seeking intelligence in interstellar space is I don't often find it in academia.
Well, I think addressing it helps. I think what you're doing helps. I think these kind of conversations do help because I don't think a lot of people are aware of the kind of resistance that you face. And I know it's a lot of what you discussed, and I wish it was less. But it's important for people to know that you have to go through this kind of nonsense.
Well, I don't
Especially when you think this object, 3i Atlas, is weird.
Yeah.
It's weird.
You know, I served in the Israeli military, and we parachuted, we drove tanks. I was in a special unit that allowed me to finish my PhD at age 24, and then the SDI, the Star Wars initiative, President Reagan brought me to the US. And I remember while serving in the paratroopers that there was a saying that sometimes you have to put your body on the barbed wire so that your friends, colleagues, soldiers can
climb over your back.
Yes.
Oy.
And as long as I allow young people to innovate, as long as I attract kids to science, I did my job. It's not about me, you see. It's about humanity getting better. And it will not get better with AI, as we discussed. It could get better with alien intelligence because we will realize that there is something else out there that is more accomplished than we are.
Right.
So it will serve as a role model. You know, in 1882, Friedrich Nietzsche said, God is dead. And since then, we had a century of modern science and technology where we feel hubris. You know, we are arrogant. We're at the top of the food chain. You know, we go to restaurants, we eat other animals that are less intelligent than we are. But just think about it. If it turns out that we are not at the top of the food chain in the Milky Way galaxy, there is someone more intelligent than us. If that someone comes to visit Earth, will we be served in their soup?
I wouldn't think so. I would think there's plenty of other things to eat that aren't intelligent. I mean, that's sort of the deal that we make here. We eat things, but we try not to eat intelligent things, which is not entirely true because we eat a lot of octopus.
Yeah, I had this dilemma in
octopus
Boston.
Is quite
yeah.
intelligent.
Yeah.
And then there's a lot of people in indigenous tribes that really prefer monkey meat. You know, those are human beings that love to eat monkeys. That gets a little weird too. But I don't think they're going to travel all the way over here to eat people. I think if we were that delicious, we would be eating each other a lot more
No, it's probably
often.
a situation where we are just like ants in the cracks of a pavement, and there is a biker passing by, and we are trying to make sounds and, get attention. We think it's about us. It's always about us, according to us. But it's not about us.
Well, it's not about us cosmically when you take into consideration the vast spans of the universe. But if I was an intelligent species and my curiosity led me to explore other intelligent species and they were far more advanced than us, I think they would find us quite fascinating. That was the argument that I got into with Neil deGrasse Tyson, where he was like, I don't think we're that interesting. Well,
Right.
they would visit us.
You
I'm
have to keep in mind, he's not a practicing astrophysicist. He's not writing scientific papers. I write a paper almost every week.
Right.
I'm in the trenches doing science. It's very different. It's just like, you have soccer players and you have commentators on the bench,
Right.
And you can be a commentator, popularize science, but the difference is that as a commentator, you will never score a goal.
Well, that's my position as a UFC commentator. I don't get in there and fight people. I understand the fighting. I can do my best to help explain it to people, but
Right.
I don't do it. So
A few months ago,
defer to experts.
A few months ago, I was at a gathering, and there was a cocktail hour, and it was with celebrities, and I saw Margot Robbie standing, and of course, I have nothing to offer. What kind of opening line would I start a conversation with? I didn't know how to start a conversation. So
Right.
I was just standing on the side, and then someone came with my book, Interstellar, and said, would you mind signing it for me? And so I signed the book, and she noticed it, and she came over and said, are you Avi Loeb? I really wanted to hear more about what you're doing. And we started the conversation for 20 minutes. Then I gave my talk, and Jerry Bruckheimer was in the audience. He is one of the most accomplished, you know him. He came afterwards and said, I just finished F1. The movie, and my next one is about a scientist like you searching for UAPs and trying to figure them out.
Oh.
And then I saw Adrian Brody was standing there, and he told me, I really want to become a scientist. I always wanted to become a scientist. I said, it's not too late. And then I went to Jerry and said, look, he should be your leading actor, because Adrian really wanted to become
casting calls. Look at that, figuring it out for them. Interesting. Look, science fiction is one of the most popular genres of films ever because everybody has curiosity about it.
But nature might be much more imaginative than the best script writers in Hollywood.
Very likely.
And so if we look up, we might get a much better movie. And there is actually the Rubin Observatory funded by the National Science Foundation, Department of Energy in Chile. It was inaugurated in June this year.
Is that the VLT array?
No, the VLT is a very large telescope by the European Southern Observatory, but this one was funded by the US, and it has a 3.2 gigapixel camera monitoring the southern sky every 4 nights, and it's an amazing survey telescope. And by the way, Sphere has a display that is the biggest in the world of 14,000 by 14,000 pixels.